Welcome to the series of problem solving session for the course Surface Water Hydrology. This is an NPTEL online certification course being taken by Professor Dr. Rajiv Mehdi from the Department of Civil Engineering, IIT Kharagpur. I am the teaching assistant for this course. I'm Aman Srivastava and I will be solving the numerical problems based on the first week introduction to hydrological processes. So whatever the lectures that has been taken with regards to the week 1 introduction to hydrological processes, I will be solving the dedicated numerical problems based on this topic. The idea will be to have a hands-on experience on solving the problems as well as also realizing the significance of hydrological processes. So let's begin. So today in this lecture we will be focusing on two concepts. Firstly, residence time, and secondly, water budget equation. So before we go into the details, I would like to let you know that the water budget equation will be not just limited to week 1, but the problems on this topic will be repeatedly used in the subsequent weeks as well. So every week there will be problem solving session where we will be solving problems on each of the topic that will be taken in each week. So for this week our focus will be on estimating the residence time and solving problems on water budget equation, which is also called as hydrologic equation. So let's start solving the problem. Here is the first problem on the concept of residence time. Let me read the problem. Estimate the residence time of global rivers by assuming that all surface runoff to the oceans comes from the rivers. Use the information given in the tables, which is there on the next slide. So here we need to find out the residence time, which is very much clear, and the residence time has to be calculated for global rivers. So here we want to find out that the water molecule which is there in the rivers, how much time does it take to shift from one hydrological system, that is global rivers, to another hydrological system, which is the oceans. So here the mode with which the global rivers will reach to oceans is surface runoff. So here it is a direct assumption for this numerical problem that all the water or the water molecule from global rivers will reach to the ocean only via surface runoff. So we are ignoring other routes that can lead global rivers to reach oceans. For example, we are not considering the groundwater recharge or groundwater flow towards ocean. So keeping this in mind, let's switch and let's see how these tables can be utilized to determine the residence time for global reefs. So this is the table which provides estimated world water quantities. It was introduced by UNESCO in 1978. So here we can see that on the left side here in the table we are having items regarding ocean, groundwater, soil moisture, polar ice, and likewise. So here we are actually showing the area cover of all these processes or the sources of water on earth. Then we are also here listing down the volume cover of each of these items. Then we have also shown here the percentage of total water, how much is the contribution of this water to the total water which is available on the earth, and we are also focusedly estimating the percentage of fresh water. So if we look towards the problem once again, yes. So here you see that we are supposed to find out the residence time for global rivers towards ocean, right? And the mode is surface runoff. So kindly keep all these terminologies in mind: global rivers, surface runoff, and oceans. And then let's try to see how these informations can be utilized from this table. So firstly, I would like to take your attention towards this value, which is rivers. So here we see that the volume of the river is 2120 kilometer cube. And another important attribute that I would like to have your attention is on how much river water is flowing from the land, because it has been told in the problem that the water molecule is traveling from global rivers to ocean via surface runoff. So surface runoff is possible from the land. So here we see that the rate at which the water is flowing from rivers to ocean is 44,700 kilometer cube per year. Right. So having these two information, let's see how we can solve or how we can actually identify the residence time of the global rivers. The residence time, that is TR, is the average duration for a water molecule to remain in the river, and it is given by this equation. TR is equal to volume of water in the rivers of the world divided by average flow rate of the water in the global rivers. So just now we have seen from the table that the volume of water in the rivers is 2120 kilometer cube, that is the volume, and the average flow rate of the water in the global rivers. So this is that flow rate where the global rivers is flowing towards ocean via surface runoff. So we have taken the flow rate of the rivers via land, which is 44,700 kilometer cube per year. So if we solve this equation, then we will get 0.0474 years. So converting this year into days, we find that the residence time of the global rivers is 17.3 days. So in a general sense, it means that the water molecule which once enters in the rivers will stay in the river system for 17.3 days. I hope you were able to follow this question and would also be able to solve it by yourself. However, to make it more informative, I have taken other aspects as well. So let's solve another problem on the concept of residence time. Let me read the question. Estimate the residence time of global groundwater by assuming that only saline groundwater runs off to the ocean. Use the information given in the tables, which is on the next slide. So here now, instead of global rivers, now we are focusing on global groundwater. And this global groundwater is also running towards ocean. And see, there can be many types of groundwater, but our focus in this problem is that how much is the contribution of the global groundwater via saline groundwater only. So how much is the saline groundwater running towards ocean is the focus, and then we would like to find out the residence time. So let's see how we can utilize this table to estimate the residence time. I would like to have your attention on the saline groundwater volume, which is, you can here see 12870,000. It is that kilometer cube of volume of water which is there available as the saline groundwater. And the next focus based on the numerical problem is how much is the flow rate of this groundwater towards ocean, and we can see here that it is 2200 kilometer cube per year. So this is the flow rate, and here we have identified the volume. So let's see how we can utilize this information to find out the residence time. So as we had discussed previously, what is the residence time? So the definition is still there on your screen. And we are now interested to find out the residence time for global groundwater. So here we are focusing on volume of saline groundwater in the world divided by the average flow rate of the global groundwater. So if we substitute the values that we have seen previously in the table, here it is 12870,000 kilometer cube is the volume of the saline groundwater in the world, and it is divided by the flow rate of the global groundwater, which is 2200 kilometer cube per year. Solving this, we get 5850 years. So you can see And you can also realize that once the water molecule enters in the saline groundwater system, the water molecule will stay in that system for 5850 years. So now we can actually compare and see that the time for which, the residence time for which the water molecule will stay in the river system is merely 17.3 days, while the same for saline groundwater is close to 5850 years. So likewise, you can also find out the residence time for pure groundwater or fresh groundwater resources as well. So let me take this discussion further and solve another problem on the concept of residence time. So let me read the question. Estimate the residence time of global ocean water. Now we have been actually solving problems where we were focusing like how water molecule is traveling from global rivers to ocean or global groundwater system to ocean. Now we are interested to find out like once the water molecule enters in the global ocean system, then how much time that water molecule will stay in the global ocean water resources. So let's try to find out the residence time for global ocean water using the information given in this table. So you are already now aware of how to use this table. I would like to have your attention on the volume of water available in the ocean, and you can see it is a massive number. It is 133800000 kilometer cube of water available in the ocean. And another attention that I would like to take is on the runoff, the total runoff which are actually contributing water to ocean system. So here we see, interestingly, now we are considering the runoff to oceans, not only from rivers, not only from groundwater, but now we are interested like whatever is the source that is leading water towards ocean, that we will be focusing. So we have added the flow rate from the river and flow rate from the groundwater, and the sum total is the total runoff, which is 47,000 kilometer cube per year. So keeping the same concept in mind and do not forgetting the definition of the residence time, here we need to focus on the volume of ocean water in the world and divided by the average flow rate of the total runoff to ocean. So here when we say total runoff, it is accounting both the runoff via rivers and the runoff via groundwater resources. So substituting the values from the table, here it is, and solving this ratio, we will get 28,468 years. So now you can see like how the residence time is actually increasing. So just to recall, the residence time for global rivers is 17.3 days only, while the same for saline groundwater was somewhere more than 5,000 years. And now for the water molecule or the time the water molecule will stay in the ocean system will be 28,468 years. So you see that as we are changing the water system, the residence time is also changing. And now you can actually realize like how the water molecule is staying in a particular system. So these informations are actually useful while studying the concepts of hydrological processes, where we are interested to find out how each of these hydrological systems are linked with each other. And here the residence time actually help us to provide information about how much will be the time taken by a water molecule to flow from one system to another. So I hope you have been following the conversation that we have been doing and the problem that we have been solving on the concept of residence time. I request the viewers that if you have any doubts regarding these problems, you please write these problems in the comment section. Also, just to let you know that this video will be soon available on the YouTube, and I'm pretty sure that you will be watching this recording on the YouTube channel. So feel free to post your questions or add your questions as comment in the comment section. Also, you can write your concerns and doubts in the NPTEL chat section.